starting event.
Just ping me on Slack or something.
Okay. Thank you. Thank you, Sharon. Okay, guys, I apologize for starting so late. And that's because this is a new platform. It promises to be much better. But the result is that we're starting 15 minutes late. So those people who very nicely waited, thank you very much, guys. Let me turn out my assistant. Got it. All right. So here is the slide deck. What I want to do is very informal. You see, I'm sitting here, waving at you. Could you confirm that you can hear me and you can see the slides? Somehow somebody they tell me that yes, all is good. I think there is a way to chat there. Enable chat. Yes, it is enabled. So I hope it is. There are a lot of people whom I know. So if you guys could chat anywhere, like Laszlo, can you see things? Are you in the meeting? I don't want to start talking without any kind of confirmation. So if you could do this, that would be great. There's the chat. I'll type there. Okay. Can you guys hear me? Can hear you only, that means me, Mark, right? Okay, perfect. That's wonderful. So again, thank you very much for doing this. Let me start the presentation because you've been waiting long enough. So definitely it's the time to start. Okay, what I will do is this. I'll do the slide, clear from the start. That way you see all of the slides, and later on we'll invent some way for you to communicate. But for now, I want to do this, and please chat. Let's see if I can hear your chat. Yes. So, oh, yeah, you're saying audio is really bad. How about if I move my headset? Is that any better? And I will take away my unnecessary face there. Turn the camera off. Okay, wonderful. Thank you, guys. Trying to find this. Okay, camera is off, screen is on. Let us go. So here's what I want to do now. You see my slides, so I'll do this slide share. You should be seeing all of that. I'll try to do my best. I'm sharing the slides. Once in a while, though, I will be going away from my slides and going to the screen. That is because I also want to make it informal, and I want to show you what's going on in the real world, show you the screens, show you the browser. Okay, so first of all, we're talking about basically how people, and specifically Google, is the first to democratize machine learning. Well, that's how my daughter democratizes machine learning. She is doing those cartoons, and she says that it used to be that the data scientist was called a geek, was not very popular at parties at all, was a loner. Now it's a totally different story. He's in big demand. But there is a bit more to this. This guy called data scientist didn't exist. In 2008, they even invented the whole term data science. Previously, supposedly it wasn't there. Now you meet a lot of people who have degrees, advanced degrees in data science, so it became a science. real quick. As you see here, it was called all kinds of other names. It was statistics, it was analytics, it was market segmentation analyst. But now it's a different story. That's the story today. It is all about AI. You really need to say you're doing AI or else you're out. If you're any company, let us say you're dry cleaning, then of course you're doing AI to find out the best possible combination of cleaning agents, whatever worked for you, whatever didn't. You use the data. In other words, that's a whole new world. The AI now has come into prominence after so many failures. There were times when many AI startups failed, and the whole concept was bad and the word AI was bad. But now it's different, as you can see from those robots. So what makes AI alive is machine learning. That is the technology that makes it alive. That's what we're going to talk about. And the very first machine learning came out in about 1960s. And what it was doing already, an imitation of machine learning by doing this. You talk to a live therapist. That's the guy who knows all about you because you tell him all about you. And he invents new and new questions. He engages you into conversation. So I'll share the screen. I'll stop my slides. Since I'm sharing the screen, I will be able to just open it in the browser like this. And here's Eliza, computer therapist. And you can all try it. You see the URL. You can try that URL. She says, I'm Eliza. So let's say, are you interested in our webinar, right? Interested in maybe in artificial intelligence, maybe not specifically our webinar, intelligence. And I'm trying to give her as much information as I possibly can. Why are you interested in whether or not I'm interested in artificial intelligence? She's trying to turn the conversation to me. Okay, well, I am doing AI. She may not know the term. Let's see. Do you believe it is normal to be doing AI? Well, okay, we're getting fun. Yes, many people do AI. Are you sure? Okay, great. So we see the basic idea, but I'll tell you about the technology that is behind this. The technology that is behind this is you give me the rules and she programs these rules. So there is a human in the middle, that guy who designs the rules. I'll show you a very simple illustration of that. I'm doing a little chart, and here's what it was, and here's what it will be. It doesn't want to show. Here's my OmniGraffle. I want to show you the next thing. So here's what it used to be. You are the programmer, so you get input data. Okay. You also get some rules. And then your computer system gets you the output. That's your computer system quite clearly. You get the output right here. Okay. Well, now things are changing, and you just change that around. You put your output right here, and you put your rules right here. And that's the essence of AI. I'm giving my system the input data, but I'm also giving it all of the output data. What it gives me are the rules that it takes. So at the time of Eliza, those rules were also done manually. That was not this. Later on, I'll show you how things are better now. So let us continue with our slide deck. I had to do these interruptions, but we can continue now. So when we're talking about Eliza, then we can think about performance. We can think, can Eliza really do well? We need to measure what does it mean to do well. So in this case, we have those three things. We have performance, which is doing well. And then we have the experience, which is our input data. And then we have the model or the rules. And what I'm trying to do is to maximize the performance. Let's make it a little bit more concrete. Let's say Eliza is trying to do dialogues. So all of the inputs are experience all of the dialogues in the world. They didn't use all of the dialogues in the world for Eliza. They just used some small measure. But then they also used the input as the rules. Today they would do better. Today they would create a system that learns from experience. You'll put a lot of experience and you would also give them the final product. I'll show you how we mean. Go back into our slide deck, then I have some demos. So those demos will tell us exactly how we need to do this. Let me try to go to this demo. That's the Google Assistant demo. If I click on this, then I hope you will hear that. If you do not, I will do this. I'll give you that link and I will chat that link on our conversation, okay, so that you will be able to do it on your own. You'll hear, but I'll tell you what I want you to hear. So I'm trying to run this. Let's see if that runs. If it doesn't, I'll just describe to you what it does. Okay, good. Here is this dialog, and I'm running it, and well, tell me if you can hear that.
Sure. What time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service you would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Okay, so I hope you heard it. If you didn't hear it, you can hear it on your own. But you see, that is where the machine learning is today. That is the Google Assistant. It gives you a very lifelike dialogue system, much better than Eliza. It understands what the people are saying. It can respond. I'll show you exactly how you would do this. One thing that you may notice if you did hear the dialogue, or even if you clicked on your own and you heard the dialogue, you can notice that in order to pass as a human, you need to sound a little bit stupid. Not that that particular lady sounded stupid, but she had delays, very human delays. She was always thinking, then that is giving yourself time to think. Computers do not really need it. But nevertheless, that's what she did to sound more like a human. So we said that you first give you the measures of what is a really good working system performance. How many times can you fool a human that in thinking that it is a human? The next step, and by the way, that is the less technical step, is this. You open any book on AI, machine learning, and then it says, well, just enough linear algebra for you to understand what I'm going to talk about. Well, that is a famous problem that everybody is fighting with. Can I do it without linear algebra, or I cannot? Here I'm showing why linear algebra would be extremely helpful. But continuing, we will talk about whether you do need it or not. So the next step is here is the today modern AI, and that's how it works. Today modern AI is modeled after a human brain. An artificial intelligence tries to imitate exactly what the humans do. And it does it in a very simple way. It says, well, we have multiple neurons in the brain, and those neurons talk to each other. Well, let's imitate this. Let's create artificial neurons. Let's give them power to either say yes or no, and we will feed them some answers. These yes or no's will be combined in the next layer of propagating, and in the next, and in the next. And the end result will be something like what I will show to you in a second. So first of all, you will be able, if your network is smart enough, to detect first the features and then go into bigger features and then finally the faces. Secondly, you will be able to do those fine experiments. I will click on one of them and then I want you to play with it as well. I'll give you a little time. It says quick draw. So let's draw. I'm a very bad drawer, but I mean, maybe some people are also not so great as an artist, or else they would not be in this seminar. So here it is, and it says draw grapes. Okay, I'm going to draw some grapes. Let's try. It says I see circle or bicycle. I see scissors or peas. That's what it said. Okay, it was pretty bad, right? In any case, you can play with it. Okay, I'll give you that link. It says sorry I couldn't get it because I don't know if you hear that or no. But I'll give you that particular link as well. Okay, and you will be able to play on your own. That is what neural networks do for you. They allow you to input a picture, let us say, or some other input, and then they are able to classify it. What kind of thing was that? Since we're still sharing screens, I'll show you exactly what's inside the neural network and how that works. For that, you'll go to something called Google Playground. I'm doing Playground, and I'm giving you that link now because you see what I'm doing. Just the first part of the link. So I'm chatting that to you as well. I'm closing all the other ones that we do not need. And that's the one where I can chat to you. And feel free to follow what I'm doing with your own experiments. That is Google giving you a real live experiment in neural networks. And for example, here, I need to decide whether my inputs are blue or orange. So blue is the real data that I will get. Orange is the real data that I will get. And the new point that will come, that's what I will be using my machine learning for. So this is a live neural network. It has one hidden layer. That's the layer. So this imitates all of my inputs. This imitates all of my outputs. My inputs are X and Y, a point here. Let's say that point. I need to know whether it is orange or is it blue. And I need to create a model that will reflect it. So let me try to run neural network. Because as you can see, what they're trying to tell you is that you don't need to understand what's going on. It is just running neural network, and it will hopefully get what you want. So let's see if it can. That's surprisingly enough, it got it. Wasn't all that bad. If you're a data scientist, then you will know that for such shapes, you would probably like to add more predictors, like the square of the original data. That's something data scientists do all the time. With all the possible connections, we'll talk about what those connections are. And now let's try to run the game. It finds an answer probably even better than before. So what is this? This is an imitation of the human brain. These are the inputs, maybe these are my eyes. These are the outputs, that's what I'm looking for to classify. Is it an internal circle or is it the outside part? And these are the deciders. Now, my inputs go to my deciders because they need to know something about my data. So you see, that goes to every one of the four deciders or neurons. And that one too, and that one too. That's called a fully connected network. Now here, they're combining those coefficients according to those numbers. The numbers are spelled out here. If you see, I'm mousing over those numbers, and these numbers show me how much of x1 goes into the final decision, how much of x2 goes into the final decision, and so on. Since I have 4 different neurons here, the end result is that they all come with different coefficients. The hope is that after we go back and forth long enough, we get a good solution. That is the whole neural network idea. And here is how many times did it go back and forth. So I allowed it to go back and forth 38 times. In theory, it can keep running. If I click on this, and almost nothing changes, you see that maybe it's increasing just a little bit, but the neural network, it tries to always improve itself. So it will keep running forever. So here you ask the data scientist, should I really train it forever? Am I getting better and better all the time? And often the advice is no, train it as much as you can, but don't go overboard. That's already in the area of data science. What I wanted to show is that Google gives you the tool where you can pretty much imitate what your neural network will do. The next step is coming. So here we are. So far we have come up until now, and now exploration of what's going on. I showed you those pictures. I did show the Google Assistant. Now let's talk about what's going on as far as real computers. I showed you that neural network, this one. And I showed you that it has a few neurons. Well, the human brain has 100 billion neurons. So that will be a pretty involved network. Today's modern networks, they go up until 100 million neurons. So we are still about 1,000 times more powerful. Our brain is more powerful than the most powerful network today. Nevertheless, there were times where those networks were much, much less powerful, and this is the 80s and the 90s. In the 80s and the 90s, the neural networks were just a subject of research, but nothing practical. And there was a time when that research was not even funded. For 10 years, there was a time period in the States, in the United States, when the research was proven wrong and not funded for 10 years. Canada continued for all these 10 years. So that's an interesting thing. You often find Canada publications, that's why. But then something happened, and this is what happened. You got more computing power. Some people will date it in 2006. That's when the first neural network, the LeCun neural network, has beaten the best of the standard algorithms. And some people will date it at 2012 because that is when you got significant practical results. But in any case, however you do it, the neural networks, because they have so many different inputs, so many different deciders, they can get much better in their resolution. For example, today, X-ray analytics is better done by computers because they diagnose more problems. Or the cat or dog recognition, a famous beloved problem, is done at 98% by computers, 95% by humans. So that is because those neural networks can go potentially to reflect all of the inputs that you have, as opposed to humans who don't. They humans, they always start from zero. The computers, they keep learning. So with the more computing power and with the capability of neural networks able to reflect every wiggle in the input data, as long as you have enough input data, you get amazingly precise results. This is our Facebook face recognition and other famous results like fraud detection and so on. So what are the tools? Now we're coming to how can I use it? Okay, that's all very nice. Some people use it. What do I have to gain from this? The answer is yes, there are tools. Here's the Spark. That's what we usually teach, Spark machine learning. Here's the same thing. Well, Amazon will say it's not the same thing. It's much better on SageMaker. But they're very similar. In fact, you can run Spark on Amazon, or you can run Amazon algorithms, some of them in Spark. But here's an interesting thing. This is a new library by Google. So it's called TensorFlow. I'll tell you why it's called TensorFlow. But the year that Google open sourced that, right here, 2015, is when it shot up in popularity. And then it continues growing up. And until the point where you see that it leaves everybody in the dust by popularity, that's the number of stars on GitHub. And if we go to GitHub, just to verify this, let's go to GitHub. Okay? And let's find the TensorFlow there. TensorFlow. And that's the right one. Okay. So how many stars does it have? Well, 116,000. So that's how many people thought that's a very interesting project. How many copies do you have? 70,000 people thought that let me make my own copy and maybe suggest something. The end result is that you have almost 2,000 contributors and 45,000 comments. Well, that beats essentially almost everybody. And that is the Google library. So it's very easy to use. How easy, I'll show you. And it has implementations on any computer, especially on Google computer. So we'll come to this. For now, this is the job popularity. please don't be deceived. Don't rush into this learning TensorFlow just because of the job popularity, because it's popular on its own, but it's not all that popular compared to other skills as yet. Why is it called TensorFlow? That's because a tensor is a general name. If you have just a number, it's called a scalar. If you have a couple numbers, 5, 7, 10, that's a vector. Many numbers is a vector. If you have many vectors, well, that is a matrix. And if you add yet another dimension, for example, let us say you have a matrix of RGB, the red, green, blue values for a picture. So first you show all of the red, then all of the green, and then all of the blue. Therefore, this is 3 matrices. 3 matrices is a number cube, but the generic name for that is a tensor. After that, everything is called a tensor. That's why it's called a tensor. In other words, you can think of it, if my generic number can have any dimensions, well, that's a number flow, not a tensor flow. Why is it a flow? That is because TensorFlow says I go from one step in my calculation to another, and my data flows with me. So that's the reason for the name. That's where you can play with this TensorFlow, and I just showed you that. But the next step is this. Google offers it to the whole world, and they even offer it in not necessarily an installed version. Now, in my case, I have the installed version. What I would do is I would open the terminal, make it a little bit bigger. I'll say Python. Okay, so it's Python. And then I will say import TensorFlow as TF. Okay, so now it's checking, is there such a library? And thanks to Google efforts, there is. From now, I can do anything about this TensorFlow. I can show you what that is. It's TensorFlow. So that is what Google gives you, but not everybody wants or could install this. So they give you this collab research. Let's look at that. This is where you can play with TensorFlow on your own without installing anything. Let's say, hello. Well, I really want to go to some interesting code. Let's say we go to maybe examples. Okay, here's an example. That's the code. Can I run it? Okay. Not sure where does it show the result of my running. So let's do something else. Let's look at other examples. Visualization. Okay. So this is the code. Can I run it? Let me click. Okay, it ran. Just to prove the point, again, it ran. So this is visualization part of this. Well, what's nice is that no setup. You see, it's all in the browser. I can even ask for GPU, which are in general quite expensive, and they will give me the GPUs. So that is what Google gives you to you for free. And one of the ideas is that, look, it's so easy. The other idea is, look, it's so much needed. That's what you hear everywhere. People say, hey, your software sucks. Why? That is because it's not as smart as my phone. So they always have something to compare to. They can compare to phone that's from Google or to phone that's from Apple, and they are very smart compared to our software. So people armed with this comparison begin to say, could you do something like your phone? I don't like your medical software, the way it runs, because it's incredibly stupid compared to my phone. So it seems that there is a need to put this artificial intelligence into every piece of software and justify the claim that we really are using your data to give you the better experience. So let us look at what is Google showing. That's one of the lectures, you can find it. And 2017, they talk about effective TensorFlow for non-experts. I don't think that completely explains to non-experts what TensorFlow is, at least the subject, or what they will gain from it. But this is 2010, and they're saying, we're going higher. We're giving you some very easy ways of using machine learning. And then they're saying, and you know what, anybody can do this. Here is the programmer that is not an expert. That's the continuation of the first lecture. He's not an expert in computer science, or at least not in machine learning. And he starts by saying that, guys, I'm a programmer, right? I don't know all of that complicated terminology, but I still want to use it. Is that doable? So he says, when I hear linear regression, my mind blows up. Okay, so granted, everybody who hears linear regression and his mind blows up, he will do the same thing. He will wonder, can I do it? And then this guy explains how, yes, you can do it. So at least the hope is that everybody will start using AI, and then everybody will be putting intelligence into their software, and that seems also to be a need. I know, for example, about one of the five largest companies that they said 2019 is the year of AI for us. AI should be everywhere. And I also know that we teach some other companies who already started on this transformation last year. So 2018 was for them the year of machine learning. And as I go around and teach different groups, I hear that they are already implementing whatever those machine learning methods that I showed them or somebody else showed them or they found them in the books. So next interesting step, and that's purely my hypothesis. You do not have to agree with that, but I hope by now you see that is the direction. Make everything intelligent, and here are the libraries to do it. So one interesting step is that where will these libraries run? I'll leave the answer for later. Let's look at the hardware. It used to be that CPU were it. Its CPU can do any kind of calculation, and they were growing and growing, and it was the Moore's law that you have 2 times more power in about, let's say, 18 months than it was 24 months. And then it stopped. CPUs cannot grow anymore. In 2012, that was the end of it because you need to make the circuits smaller and smaller, and that generates more and more heat and overheats. So instead, they started doing multiple cores. You can have from 2, 3, 4, well, not 4, 3, 2, 4, but I've seen machines with 40 cores. So that is 40 times more powerful. And each CPU is not more powerful. And then the people realized that, well, why don't we continue with this idea? Let's put 1,000 CPUs. That's a GPU. Initially originated as a gaming platform, but then expanded into a complete computing platform. So you would think, well, that's it. It stops there. But no, there is a new idea called ASIC, or Application Specific Integrated Circuit, and that's how today you mine bitcoins. Nothing else competes with ASIC because ASIC can do just that. It can only calculate hashes that you need to mine bitcoins, but it does it 1,000 times faster than the GPU. So the next step is, well, and that was predicted, by the way, by the great guy uh, of Microsoft Cloud. He's a university professor at Austin. He now works at Microsoft. His name is Berger. You can look him up. So he said that things will happen and people will start creating ASICs, application-specific integrated circuits, for machine learning, for other applications. Well, it did happen. That's what Google did. Based on the popularity of their library, they created a new accelerated circuit that's called TPU, TensorFlow Processing Unit, Tensor Processing Unit. Okay, and that's another 1,000 times faster than it used to be. So here are the numbers. Well, the nice thing would be to put all of that together and create a computer. Well, that's what Google has done. They created a computer. That is the computer of all the CPU units. So that's a machine learning computer, as it is thought to be the thing right now, and it is available as of March this year. It is now available in the cloud. So that is an interesting thing. My hypothesis is this: is that Google makes everybody dependent, like on drug, dependent on machine learning. And what's the best place to do that machine learning? Well, of course, that's the GPU. So that's one scenario that you can think about, and that's why there is such a big push everywhere. So it's interesting that on the one hand, it benefits everybody. On the other hand, it also benefits the creator. So the next step, what now? I'll just show you a few books that you might want to read. There are so many ways to learn. You start with books, you go into online courses, then you go maybe into classroom courses. That's what we do. But I first wanted to give you the first introductions, if you have not seen them. Andrew Ng is the founder of Coursera, professor at Stanford, and he founded Coursera based on the very first experiment of opening a course online 40,000 students signed up, and that was the beginning of Coursera. So he wrote a book called Machine Learning Yearning. You can find it on the web. I think he's either completely done or just almost done with every chapter, but they are free. And he teaches you how to talk about machine learning on a very high level, no technology at all, but some basic ideas. Now, you will not be surprised that this is possible because what is machine learning? That's automating something that we humans find it very easy. We recognize our friends. Let's say it's early morning and I need to see something. Is that my friend or no? So usually I can do that. I can say, oh, that is my friend whom I know. Well, computers will have lots of hard time doing this. And when you automate this, this is called artificial intelligence. So that's very clear. They are trying to get up to our level. And therefore, talking about this is very reasonable. That's exactly what Andrew Ng does. The next step, and that's a smaller reference, I would say, is the deep learning book that has everything you could possibly need. It starts from the beginning introduction, a little history, then it gives you the second phase. That's where if you are a programmer, how can you use machine learning? And the third one is if you're a PhD student, well, what's coming up? So it's very complete. And the best portion is that these people really know. There are enough books today written by people who don't quite know, don't understand, and sometimes misunderstand. Well, that book has no such problem. It's available online. You can also buy a paper version with this very nice color. And the next book is Spark. So Spark is one of the leaders in machine learning as well. And that's the latest, about 6 months ago book. And it is also very straightforward about what's going on in the Spark world. It gives you an internal view. So that is a great book for machine learning as well. And finally, before people start machine learning, they often miss the very important part, where humans come in. And where they come in is let's think about the problem in the first place. What are we doing here? And that book is about feature engineering. It talks about what could you try to do? How could you organize this data? So I think together between Andrew Ng, who talks about what kind of machine learning problems you want to solve, and Alice Jane, who talks about how would you start translating this into reality, and then technology, that probably covers everything. So the final advice is this. Andrew Ng feels that while everybody should do this, we live in the very exciting times when you can put intelligence everywhere. And the way he wants you to do it is by reading a paper that you like and then reproducing those results. Facebook did facial recognition, you can do it too. Do it 20, 30 times, you'll be quite proficient. It's interesting that there is a different idea by Thomas Mikolov. Thomas Mikolov is an automatic translation, text analytics. He did much of Google translation. He invented word to vector. That's how you take all of your texts and convert them to numbers before you feed them into the machine learning. So he says, guys, I'm tired of you. You're doing those Andrew Ng type of machine learning experiments. That's all more and more cat recognizers. It's essentially the same thing again and again. What we should build is a machine learning algorithm that learns about how to learn. And that will be our last program. It will learn from then on. I'm a little bit exaggerating. That's the science fiction area. But his point of view, and he's not the only one, Google is working on the same thing. Can we eliminate at least a large part of machine learning expertise and leave it over to the computers? So that is, I'm leaving you with two answers. That's pretty much my style. So I'll stop this and I'll go over to see if now we can have a little chat. You can ask your questions here, okay? And if you have any questions, then please do so now. We'll have to type because of the limitation of that platform. If not a problem. You can always find me. You can go back and reply to this link. So if you have any more questions or if you need any training, hint, that's okay. So thank you very much, everybody. It was a pleasure talking to you. And if you don't have questions right now, we'll stop it. But you will be able to to ask those questions later on. So everybody has a great day and a great weekend. Thank you.